All right, let's dive in. Today, we're putting on our detective hats because we are going to solve one of the biggest mysteries in technology. Why do our super smart AIs sometimes get things so wrong? It's time to open the case file.
You've been there, right? I mean, we've all been there. You ask your AI a perfectly simple question, and it comes back with an answer that is just baffling. It's confidently incorrect, maybe a little weird, or just totally useless. It feels like a total black box. But today, we're going to find the keys to unlock it.
I mean, come on, that's kinda cool, I guess. But it's definitely not helping me find dinner tonight. Now, this kind of mix-up is our first unsolved case. And while it's funny here, imagine this happening when AI is used in business or healthcare or finance. Suddenly, these mistakes are no laughing matter at all.
Right, so these AI failures are our unsolved cases, and the stakes can be incredibly high. An AI messing up a restaurant recommendation is one thing. An AI making a critical error in a high-stakes environment, that's a whole different ballgame. The pressure is on to figure out not just that something went wrong, but the big question, why?
And this quote right here, this just nails it. The difference is absolutely huge. We're talking about solving a mystery in a few hours versus being totally lost for weeks, completely in the dark with no idea why your system broke. That is a massive business impact. So, how do we solve these cases? Well, every good detective needs the right set of tools. For a long time, the main tool we had was something called monitoring. But for today's complex AI mysteries, we need something way more powerful. We need observability. So let's break down what that really means. Okay, this analogy is just perfect. Think about it this way. Monitoring is your smoke alarm. It's great. It beeps loudly and tells you, hey, there's a fire. But it can't tell you how it started. Was it a kitchen mishap? Faulty wiring? Who knows? Observability, on the other hand, is like having the full security footage. You can rewind the tape, see exactly who lit the match, where it happened, and every single step that led to the fire. It lets you investigate the things you never even expected. And that's the key right there. AI observability isn't just about checking if the system is on or off. It's about understanding the AI's behavior. It's about getting inside its digital head to see the why behind what it does. What was it actually thinking? What data did it look at? We're basically going from system logs to a thought process. So how in the world do we do that? Well, we follow the evidence. Just like a detective retracing a suspect's every move, we can follow the digital breadcrumbs that the AI leaves behind. You see, a modern AI isn't just some single magic box. It's really a pipeline, a whole series of steps. It starts when a user asks something. Then the AI has to retrieve some information. Then it assembles that into context, generates an answer, and finally gives you that answer. A mistake could happen at any one of these points, so we have to be able to investigate each one. And the way we do this is by creating something called a trace. Now, the best way to think about a trace is to just call it the complete case file for a single AI decision. And inside that case file, every single piece of evidence, each one of those steps we just saw, is called a span. It's the entire chain of events all laid out. And what kind of clues are we talking about here? Oh, it's everything. The exact prompt the user typed in, the full response the AI gave back, how long it took to think, what documents it pulled up to get its answer, and even the exact settings of the model at that moment. It's an incredibly detailed record for our investigation. Okay, so you can probably see where this is going. If we're collecting this much evidence for every single interaction, we're going to have a mountain of data. This brings up a whole new challenge. Where do you put it all? It's like trying to manage a massive police evidence locker. You need a system. The smart way to handle this is with tiered retention. For really recent cases, say from the last week or month, you keep everything, the full detailed case files, in hot storage so you can get to it fast. For slightly older cases, you move to warm storage and just keep a smart sample of the traces. And for the really old stuff, you just keep the high-level metadata in cold storage. It's all about balancing the need for evidence with the cost of storing it all. And that sampling isn't just random. A good detective knows which clues matter most. You always keep the evidence from cases that had errors or that a user actually complained about. Those are your smoking guns. Then you also keep a random sample just so you know what normal behavior looks like. And of course, just like any real investigation, you've got to follow the law. Things like GDPR and other privacy regulations are basically the rules of the investigation. They tell you what evidence you can keep, for how long, and how you have to protect it. It's super important.
Okay, so we've collected the evidence, we've organized our evidence locker, and now it's time for the best part of any mystery, the breakthrough. This is where we analyze everything, and we finally get that big aha moment that cracks the whole case wide open.
But here's the real magic. Observability isn't just about solving one-off problems. The real power is in spotting patterns across thousands of cases, so you can stop future failures before they even happen. It creates this amazing feedback loop where the AI actually learns from its real-world mistakes and just keeps getting better and better. Let me give you a real-world example, because this is where it all clicks. There was a team, and they were really struggling with their AI's performance. By digging into their trace data, their case files, they had their aha moment. They spotted a pattern. The AI was messing up most often when it was using information that was more than 18 months old. It was giving these confident answers based on totally stale data. And just look at the payoff from finding that one clue. Before the fix, human reviewers only agreed that the AI's quality was good about 62% of the time. Not great. But after they put in a fix to filter out that old, stale information, agreement shot up to 81%. That is a huge improvement, all from finding that one critical pattern in the evidence. So let's wrap this up. What are the key takeaways from our investigation today? First, you've got to go beyond the simple smoke alarm of monitoring and get the full security footage with observability to find the why. Second, use tracing to create that case file for every single AI decision. Third, be smart about your evidence locker with a tiered retention policy. And finally, and this is the big one, use all that evidence to build feedback loops and make your AI smarter over time. This technology is giving us this incredible window into how AI actually reasons. It turns that black box into a glass box. And that really just leaves me with one final thought for you. Now that we can literally follow an AI's chain of thought, what's the next great mystery we should challenge it to solve? Thanks for joining me.